All right, so we're ready to kind of dive in to the capstone project. But before you just get to building everything, you need to kind of think about what we're going to do. Now, let's take what we're going to do and talk about it a little bit. We are going to build a self-sustainable, hopefully mobile, surveillance system, right? And also Dragonboard 410C workstation. So that being said, we're going to have plenty of electrical components. Not only the Dragonboard 410C, but we're going to need to power sensors. We're going to need a monitor. We're going to need possibly maybe some other. If we're out and about, maybe we don't have access to any light. Maybe it's nighttime. Maybe we want to power some light. So you can obviously the possibilities are endless, right? So you can take anything you want and plug it into the system. We're hoping, at least. So what do we need for this? Now, first we wanted to kind of walk you through our process. So we wanted to research some components, the system components, but we want to research the system components around the needs of the system. So if we're pulling the Dragonboard, if we're taking the Dragonboard, and the Dragonboard is obviously going to be a load of the system, well, the power supply for the Dragonboard, the power adapter, is 24 watts. You have 2 amps, 12 volts, right? Ohm's law, P equals IV. The current times the voltage, you get the power, 24 watts, it all makes sense. So we're going to need 24 watts. And you can kind of go down the list of items that you want to power with this system and basically kind of mold the components that you choose and research around what you want the load of the system to be. Now, since this is, of course, the workstation for the Dragonboard, we are going to need to power that. We're going to need to power a monitor, so you're going to have to choose a monitor that's within the specs, and we will be providing you with a list of components that we used and proved to work with our system. So we will be building a mobile station for you. And we will provide you with the list of components. You can work around that list. You can choose to use the identical components if you'd like, or you can make it more robust, bigger, add more batteries, add more solar panels, bigger charge controller, bigger inverter, whatever you want. All right. So once you've decided how big the load's going to be for your system, and you've done research on the right components, well, then you can research. Maybe you want to not use just AC power, but you want to use DC power. Now, we will go a little bit more in depth in part 2 about this, but essentially, at least for the most part, every house I've seen is AC power. We will talk about a little bit more the difference between AC and DC power. Suffice to say, AC power has a lot higher voltage, and for the most parts, our DC power is going to be a lower voltage that we're dealing with in this case. So we will be using a 12-volt battery, and we will be using an inverter to step the 12 volts up to 110 volts and provide AC current, AC power. So if you wanted to use, for instance, only DC, you don't need an inverter, and you could just power it straight from the 12-volt battery. Most electronics already have regulators inside their adapters, so if you wanted to plug in for instance, a cell phone or something that requires 5 volts. In most cases, they have the little regulator inside the device that steps it down for you. There are lots of other components you can buy online that will provide step downs and regulates the voltage to whatever you'd like. If you choose to go DC, we will also talk about that in Capstone Part 2, giving you some options on some DC components that you might want to add to your system. Overall, it saves you a little bit of power, but in the long run, it's not so substantial. So yeah, now you've chosen your components. You've decided if you want it AC, DC. You're going to purchase the components. So obviously there's going to be a little bit of a gap there while you order your components, figure out what you want, get it all set up. Everything shows up to your house and you're ready to go. Make sure you read all your instruction manuals, get in tune with your components, make sure, double check your math, and then you start to build your system. From there, we'll set up our surveillance, we'll set up our Dragonboard 410C on the system, and we'll make sure that it can run and charge, and we'll make sure that it's portable, and we'll start having fun with it. All right, so I just wanted to kind of show you a little diagram of kind of a mock system that we kind of came up with here. So for those of you who aren't familiar with all the components that may go into a solar-powered, self-sustainable solar-powered system, you can kind of see up here on the screen, and I'm going to walk you through it real quick, what everything is about. So if we start on the left side, you can see it's there. It says panels. So that's where your panels start. That's where the original power from the sun is collected. The panels let out DC power. So from the panels, you're already collecting energy, and you want to send it to your batteries, right? But the problem is that with batteries, you can't overcharge them, you can't undercharge them, you have to have them properly regulated. And so in order to do that, we have a great device called the charge controller. So in between the solar panels and the batteries is the charge controller. Now again, we're going to be providing you lists for all the components that we chose to use for our system. You can shop around and find similar specification or components with similar specifications, more or less, however you'd like to pair and set your system up. So again, we're going from the solar panels to the charge controller, and then from the charge controller to the batteries. That is going to basically say, the charge controller says, oh, hey, our batteries, they're already charged enough. So let's cut off the solar panels for now. We don't want to overcharge our batteries. Or it'll get an input from the batteries and it'll say, oh, hey, these batteries are running low. Quick, we need to start charging up the batteries, in which case it'll open it up and start charging the batteries. So hopefully I would recommend pausing this and kind of following along with me, kind of tracing it with your finger if you have to. But right now we're at the charge controller, and as you can see, there's still DC flowing in to the batteries. Now, if we just hooked up, for instance, a plus and a minus to the batteries, we would hopefully get somewhere right above 12 volts. Here I have 4 batteries in series. This just kind of shows that, hey, you can have as many batteries as you want, as long as the specs match your other devices. So your charge controller, your inverter, everything has to be kind of matched or within the range of those devices. For our case, we're only going to be using one battery. So we'll have right around 12 volts, hopefully a little more than 12 volts when we measure that. If we had a device that required 12 volts, then we could essentially hook it up to the batteries, and it would just provide us the DC. We would be able to charge our item or run it off of there. So for example, the DragonBoard 410C, right? 12 volts, 1 amp. We would just be able to run a socket from the batteries, plug it in, and the adapter will take care of everything else. It'll make sure that it's only getting 12 volts. It'll make sure the amperage is right, and we will be able to power the DragonBoard 410C right from the batteries. However, we don't want to limit ourselves to just the DragonBoard 410C. We want to be able to power anything. I don't know, maybe you're hot and you want a fan. And again, like I said, you want lights. So that's when we need the inverter. The inverter, the opposite of a converter, steps up your voltage. So what we do is, you can now follow again the screen. We've gone from the panels to the charge controller, which is kind of like the brain that decides how to charge the batteries. And then from the DC that the batteries provide, we run it through the inverter. It converts it to an AC and steps up the voltage. So the inverter that we will be using, we'll talk about later. We're going to be pulling 350 watts. So what you can kind of imagine is, if we have 350 watts, or capable of 350 watts, the DragonBoard uses 24 watts. You could be charging a phone. A phone is usually 1 amp, 5 volts, so 5 watts. So now you're at 29 watts. You know, add a fan, add a light bulb, I don't know, energy saving 15 watt light bulb. So now you're pulling 15 more watts, right? So you can just start adding these things up, and you can kind of say like, oh, okay, well, my inverter is definitely high enough to power everything that I need. What you would do from there is you can, step up your inverter to give you more watts, etc. So this is kind of what we used to walk through our process. And we went from the panels, well, I should say we went from our load, what we wanted to power, and then we went to each individual component and made sure that it was capable of powering what we wanted. Again, we're going to go more in depth on this. I just wanted to kind of show you a little bit of the process and how we thought our way through creating this system. So stick around for the next video where we will talk more specific about the components that we are going to be using for our particular project. And later on, we will actually go through a fun example of something we built in the past here at UCSD. And hopefully you enjoy it. Wait around for part 2 and we'll get more involved and actually build something for you.